So we are presenting the automated political stance identifier. It's a transparent, reproducible, and theory-driven approach to text classification. This is the agenda for today. We're going to talk a little bit about why the automated political stance identifier, what's the APSI. We're going to do a quick test drive of the web application. We're going to have a more in-depth explanation of the technical details of the models that we use. And we are also going to see how we can, just a couple of examples, how to use or how to apply the APSI for quantitative or qualitative research in social science. And then we're going to have our Q&A session. So why the APSI? In recent years, we have witnessed an increased amount of available data in the form of text. This has driven the interest of social scientists to for text classification, and given the new technologies available for us as social scientists, we are trying to do this kind of classification in an automated way. However, there are two approaches that are the most common approaches to this automated text classification. One requires a hand-labeled data set to fine-tune a pre-trained model. Other approaches relying on these huge black box models trained often on noisy data. So what we are trying to do is to provide a new approach, one that it's theory-driven, that it's transparent, and so based on these principles, we can classify texts. We use pre-trained models to do this, and for now we are we have developed our models to identify stances for economic ideology, for populist versus pluralist rhetoric, and for support of democratic or liberal democratic values. The APSI is meant for researchers, obviously, but we think that it could be also a tool or a method that can benefit journalists, practitioners, NGOs, and in general the public that it's interested in understanding better political text or speeches or rhetoric. The APSI uses a natural language inference approach. For those that are not that familiar with this approach, it provides it tries to identify the patterns within texts and provide probabilistic scores. It does that by determining the relationship between a premise and a hypothesis. So we provide the model with a text, a premise, and the model will identify if or decide if based on a given hypothesis, the text is an entailment, contradiction, or neutral. So this is the pipeline for the tool. We use these core concepts in political science, in social science, that are frequently measured in expert surveys, that are frequently analyzed, but also that are of interest of the general public that we have witnessed in media debates frequently. So we decided to use these widely used concepts as a starting point for testing the method, the approach that we are presenting. From these concepts, we use the explicit wording of expert surveys, since those represent golden standard of how to approach these concepts. And from the wording from expert surveys, we developed or we draw hypotheses that we use for the natural language inference model. The model then provides the probabilities for those texts to entail the hypothesis, and from there we provide a score calculation. So again, these are the core concepts: economic left-right ideology, populist pluralist rhetoric, and support opposition to liberal democratic values. While these are the first three that we are working now, we plan to eventually expand the APSI to additional dimensions. So from these concepts, we identify the wording in expert surveys. These experts are well positioned in political science. So for instance, I'm not going to read the whole thing, but the economic left-right comes from the Capitol Hill expert survey. The wording from the populist pluralist rhetoric comes from the Global Party survey. And the one for support for liberal democratic values comes from VDEM. So from these wordings, or the wording of these questions in surveys, we developed hypotheses. For instance, for the economic left-right ideology, we developed 40 hypotheses. These are only some examples of how they look in our code. So we have hypothesis for the left, hypothesis for the right. These are for the populist pluralist rhetoric. We have 24 hypotheses. Again, some are for the populist rhetoric, others are for the pluralist rhetoric. And the same for the support for liberal democracy. Some are supporting democratic values, liberal democratic values. Others are in opposition of liberal democratic values. So once the text goes through each hypothesis, the political debate model, that's the model that we use for this analysis, provides the probability of this hypothesis to be true. It's worth mentioning that this political debate model, it's a domain-specific model. It's for political text, so that's one advantage. That's an advantage for the APSI. So the text pass through each hypothesis, and the model returns the probability of the text to entail each hypothesis. From there, the model averages the probabilities on each side and takes the difference and provides a score between 0 and 10. In case of contradiction, the APSI returns a flag. And we have also a filter that in case of a text without a stance or not a clear stance, the tool or the APSI returns an error message. We validated the results of the APSI with 147 surveys from experts. These are the results for the economic left wing and economic right wing. So as you can see, there are many cases that are close to the mean. In most cases, the APSI was within the expert range, except for a couple of outliers. For the case of populism, pluralism, again, the scores from the APSI are within the range of experts, and in some cases, very close to the mean. And the only problematic case is liberal democracy values, the support for these values. In this case, the model was less accurate in providing the scores. However, since we received this survey, this validation, we have been working on improving all three models, including the last one. However, we advise caution when using, especially this liberal support for liberal democratic values. So let's do test drive so you can see how the APSI looks like. Okay, so this is like this is the welcome page. Here you can find the purpose of the tool, some warnings, some quick text about the tool, the dimensions we measure. And when you click Start on Analysis, you are directed to this window where you can do the analysis. Here you can input a text. It's a pretty standard. You need to have a text that it's at least 20 characters, but not more than 2,000. 2,000 might seem like a small number, but still it's around 3 paragraphs. And then if you want to do larger or more complex analysis, you can go to our GitHub and check our documentation and use our model, adapting it and maybe analyzing by paragraph or by sentence. Then you can run the analysis on 3 dimensions at the same time, but it will take a while, or you can only pick one of these dimensions. And here in the bottom, you have some examples. So let's start with this classic example and analyze it with the populist pluralism dimension. So once you get the results, you get a warning message before, because we are slightly concerned of how people might use this. So we need to be sure that people understand that this is an AI-based system, that errors might happen. So you need to interpret these results with care. So once you have the results, you will see a score, a pre-established label, in this case, strong populist, and then a bar suggesting the confidence that we have that this is correct. Then we have also the why these results, which is part of the transparent part of our approach. You can see which hypotheses were triggered by the text and how much they contribute to the score. So let's try one. The second text for the left-right dimension. This talks about nationalizing resources. Again, you get the warning and you get the score, and again, the pre-label, pre-established label, and how sure we are the model is correct. Okay, let's try a couple of more. The one this is about cutting spending, but at the same time asking the wealthiest to do something. So this is classified as center, but raises a flag because there could be possible contradiction. But you can check the hypothesis and see that it's not a contradiction exactly. It's more that this text, that the way we express ideas is complex, so sometimes in this case it's triggering hypotheses from both sides. Let's run, okay, that one. This is to show you the pre-check. So if the text is not relevant or it's not possible to identify a political stance, then the APSI will return an error. I think we have one more probably. Okay, this is less clear or less obvious than the last one. But again, there are no visible stands here, so the model catches that and returns the error. So this is how the web application works. And now we can move on to the explanation of the technical details of the models. So Jorik, can you introduce yourself and explain a little bit more about this?
Yes, for sure. Hello, I'm Jorik. I study data engineering at the Hatzau-Plattner Institute. I'm there for already 2.5 years, so I'm towards the end of my master's studies. And yeah, decided to work on this interesting project to leverage the capabilities of large language models or machine learning to also help progress in social sciences. Here we see again the overview of our tool, where we have on the one side any input text statement, and through this classification pipeline where it first infers if the text input statement is actually relevant to the dimension. Then the text input statement is scored for each hypothesis in the dimension responsible. By the debate model. That is the debate model from Burnman et al. That Juan showed earlier. That is trained specifically on the task of natural language inference with corpus on from US politics. And yeah, these natural language inference frameworks allows to break more complex text classification tasks down into binary classifications that can be then aggregated in a way to also answer the more complex statement in a way that we do it here. Yes. We we score. We have then a score for each of these hypotheses and just have like a balanced hypothesis set there, because we then aggregated in the next step a weighted average to infer how far the model deviates from a center point, and that is then scaled to the range from 0 to 10. And the really interesting part here is that we, with the model and answering this textual questions, the model can stay solely in its embedding space and its textual embedding space and doesn't have to transfer information back down in numerical space that we can then access. We directly access here the probabilities from the textual space. And when we now move on to the topic relevance check, we have to, yeah. Can you move one slide further? Yes. For the topic relevance check, it is done with the same model. So it doesn't have the disadvantage of reloading any additional models which would take up additional space. And the pre-check is particularly relevant to avoid having statements that are not relevant for the dimension scored and producing noise in downstream analysis tasks, especially like in quantitative analysis that Ewan will show on later. And for the political pre-check, we can also gather the probability and really dig down if why a statement was scored non-political or political, and that really helps the transparency of the approach also in this pre-check step, which is then also done in the analysis step that we see on the next slide. There we have a breakdown of, yeah, exactly. There we have a text statement that is a bit expressing support on both sides. It says we need to stop subsidizing failure, whether that's banks that take reckless risk or welfare programs that trap people. And there we can see that on the corner left side, it was expressed that banks are at the focus of the statement. That was triggering why some left instance was referred here, but it was much stronger activated on the economic right side. And overall, with the weighted average, that produces then a score of 8.4 for this statement here. And yeah, especially like this hypothesis breakdown can really help researchers disentangle why our model scored as it scored. Yeah. On the next slide, we also did like some investigations how it is with the political debate model and its inherent biases, because with like more or less all big large language models, they have inherent biases that they learned from the training data, because in the training data, these biases can't be taken out since they are systemic in there and also in the real world, and that are incorporated in the bigger models. For that, we did an analysis to see how our models are affected by that. And for that, we used baseline text statements across the economic left-right dimension, for instance, and just swapped the who attributively said the statement. We redid this analysis for all 3 of our dimensions and could find out that the economic left-right model really is invariant to the political actors and focuses really on the content of the policy in the text statement. For the supporting of liberal democracy model, that's not entirely this case. That was also kind of showing in our validation run with the experts that we are there a bit further off. There we could see that when a text statement was attributed to a politician, the score was shifted negatively towards a more illiberal statement, but overall the shift is within the marginal range from 0.5 to 0.8. And on our scale from 10, that's not such a big shift. It also applies for the populist pluralism model, where the political debate model inherently learned when a statement is connected to Jair Bolsonaro or Donald Trump, it scores more populist compared to a statement that would be said by another politician, the exact statement said by another politician. But even for this cases, as already said, the overall effect with the score shift of 1, given our range from 0 to 10, is not so drastic. On the next slide, I just want to summarize this, our advantages that our model has compared to compared to bigger proprietary LLMs. There we have on the one side the reproducibility and transparency. The whole analysis approach here is deterministic, so our models will always score the same probabilities on the hypothesis set, and also the score calculations from these probabilities is completely retraceable, and will also always produce the same results for the same statement. Then these fully traceable hypotheses allow really the transparency of the models, so we just not get just the score of something on the range from 0 to 10, we also know why the score is like it is. And this makes systemic bias analysis that I just showed earlier possible. And the other two advantages are, on the one hand, the fairly small size of our model. We use the debate model with just 304 million parameters compared to the proprietary black box LLMs that are nowadays in the billions of parameters. That's really small, and it can run on consumer hardware, as you just saw with Johan, where he just ran it on a local Docker instance. And the whole approach is open source. The debate model is open source, and our website code that is an application of this model is open source, and also the training data used to fine-tune the NLI framework on the BERT models is documented in the research paper. And as already was mentioned before, the approach is not limited to the 3 dimensions we just focusing on here, the general framework of this entailment for hypothesis, and then calculating a score based on those probabilities is adaptable to also other dimensions, like climate change, for example. And with that, I will hand over to Yuan, who showcases how the model can be used for quantitative and qualitative analysis.
Yeah, thank you very much. So I thought I'd introduce myself quickly. My name's Ewan. I'm a researcher here and PhD student at the Hasso-Plattner Institute. My personal research looks at digital policy in Eastern Europe. So I joined the project to kind of see if there's a way that we can approach that in an automated manner. So what I'm going to talk to you about today is how I think we can approach this and apply this within research contexts. I'm going to put forward a case study, a mixed methods case study looking at democratic backsliding in the Georgian media. But if we could move on slides, I'll just give you some of our ideas that we've had within the team. So I think the tool really lends itself to situations which we have increasingly within social science, where we have large quantities of text, treating text as data, which need to be analyzed for political stance. So you might come across semi-structured interview data within your research, political corpora, some kind of social media data, or some kind of media studies, media monitoring type applications are also, I think, quite conceivable within this framework. So one type of quantitative study that I've thought about is applying this model to ideological drift, seeing how a party or a political actor could change their position over time. From my background, I've also looked into digital authoritarianism, and we have this claim from the literature, for example, that the rhetoric of authoritarian leaders is becoming less drastic and more technocratic over time, and the APSI tool is the kind of thing which could be used to test that kind of claim within the literature. Within qualitative studies, again, I think you can really use APSI as a means to subset large data sets if you're looking for particularly interesting outliers or examples of a particular type of rhetoric. Analyzing text through this can point you in the right direction to take part in that kind of study. So here I'm thinking maybe if you have some semi-structured interview data and you want to find particularly salient language, in this case, I thought it could be interesting to apply to this phenomenon that we have in Germany of young voters diverging based on gender in the way that they vote and the way that they approach politics. But if we move on to the next slide, I decided that I would apply this in a very concrete measure in a mixed method study looking at Georgia specifically. I chose Georgia because, well, firstly, because it's a context which we study within the Path to Power project and which I've studied quite closely, but also because it's a context which is outside of the training data for the model. So I really wanted to understand how does it perform when treating unseen data. As a little bit of a background, Georgia is a country within Eastern Europe, which has for a while now had serious intentions of joining the European Union and was working towards fulfilling its democratic requirements, but has seen significant democratic backsliding in recent years, particularly around the elections in 2020 and 2024, which have been criticized by the opposition with alleged irregularities. And this has happened under the Georgian Dream Party and its chairman, who's particularly controversial within the country. Following the most recent election in 2024, which we've also studied within the Path to Power project, the European Union decided to disengage with the partnership project with Georgia due to the accusations leveled at the government of spreading conspiracy theories around the European Union, and specifically that the European Union is trying to bring Georgia into the conflict between Russia and Ukraine. And so my research question, the kind of thing that I thought would be an interesting test for APSI, is to see what role media organizations play in democratic backsliding. So I took the example of Imedi TV, which remains one of the most popular media sources within the country, and which has been recently placed under sanctions for its role in supporting Georgian Dream conspiracy narratives around the Ukraine war and around the European Union. And so the kind of research question that I have for this mock study is, can we systematically identify such narrative positioning using the APSI tool? So if we move on to the next slide, I'll quickly talk through my methodology quickly. So I used a simple web scraper to scrape 100 random articles from the website, from the politics news section, translated these into English for analysis, as Georgian is sadly not supported by the model. I analyzed then each article line by line with a sentence either side for context, and then visualized these changes over time, this kind of ideological shift over time, using simple Python packages. I then used the scores that had been generated by this analysis to extract the top 10 outliers to do the basis for qualitative analysis, which you'll see. So this is a quantitative blend of studies trying to show the applications of the model on both sides. This full script I ran using our classifier script, which you can find in the GitHub. I ran it on my relatively old MacBook. It took around 10 seconds to analyze each article, which meant the full analysis time was 6 hours, which is something I think relatively reasonable when we're talking about large language models. And I think the real benefit of this is that I'm not paying for tokens. I'm an individual researcher with limited resources, and I can run this kind of analysis on my own. If we move on to the next slide, we can see the results that I've produced through this analysis. I won't go into full details because I'm sure we want to have some more time for questions. But some interesting findings we see, for example, in this graph. So each of the graphs is a changing of the scores over time for across our 3 different dimensions. And we can see, for example, in the top left of your screen, the populist and pluralist dimension. Here we see a big spike for pluralist language in 2021. This surrounded a crisis within the country around the arrest of a previous president, was a period of increased protest within the country, also around the election that had just taken place. And I think it's an interesting finding that this mouthpiece for the government has been trying to appeal to pluralist values. We all live in a society, we're all part of this, as a means to try and calm down, I think, the sentiment that we could see that was happening around that time. We also see this with this liberal spike around 2020. Again, this is measuring the affirmation of liberal democracy within these media articles that are on this website. So it shows again that it's trying to maybe appeal to more moderate voters or appeal to the idea of constitutionality and the legality of the Georgian system. But after this, we see a period coming up to 2026, where we see actually an increase both in liberal statements and in illiberal statements, which I think also reflects the changing polarization of Georgian media in this period. So if we move on to my final slide, this is where I was looking at the qualitative side. So I took the top 10 outlier sentences for each of the dimensions that we study and did some topic analysis to try and understand what are the main narratives that are used within this media. So this is one of the examples of the most highly ranked populist sentences. I'm not going to go into the kind of local context too much, but we see these ideas around a deep state, around the role of NGOs being corrupted by foreign powers. And we also see this increase in the use of language which comes from online spaces, which again is something that we see quite often within political science research at the moment. So to conclude, I think I've shown that this can be applied in both quantitative and qualitative settings. It doesn't replace the analysis that we're doing already. What it does is act as a tool which we can use to expedite the analysis process, deal with larger amounts of texts, and support our research going forwards. Thank you very much. I'll pass you on to Natasha as we go into the Q&A session.
Thank you, Yuan, and thank you all for this fascinating presentation. Yeah, let's move to our Q&A session. We have several questions in our Q&A panel. If you want to ask more, please use this option on Teams. So the first question is from Cecile Pomaret. What languages does APSI support? Would the tool be useful for classifying the 19th century French text along a dimension of support for democracy versus monarchy?
Yeah, this is a very interesting question because we have tested in the past the tool with different languages. As we mentioned, the APSI has been or uses the political debate model that it's grounded on an English speaking data set. So it's better, but at the same time, we have tested with different languages. But we have witnessed that while in Spanish, in Portuguese, in German, probably in French too, there are cases where the changes in the score in comparison to English are minimal. There are also others where the changes are more significant. So, and this is something that we are trying to improve, but we haven't done yet. The plan is to have this tool for, especially for less represented languages, incorporating deep learning translation, something like that. But this is something that the tool doesn't have yet. We know that it has some multilingual capability given the test that we have performed, but I would suggest that you test a couple of examples, test how different these are to a translation in English for the same texts. In terms of the time, it depends on how well relationship between the text and a hypothesis can be drawn. For instance, one of the texts that we showed today was from 1960, and it worked well. But of course, it depends on many things, especially how clear the stance can be identified. So my recommendation is try to test it with a couple of examples and see how it goes.
Thank you, Juan. So the next question is from Edward J. Zen. How large is the workload that needs to be handled? What kind of computing resources would be required?
Yeah, I think this is a good question for Yorick. But
Yes,
yeah, I'm just gonna say that we are, as you witnessed in a few minutes ago, if 80 people are trying to connect at the same time, it's gonna be a mess. And we're trying to solve that, but for now, go ahead, Yorick.
Yes, like currently the website is self-hosted in our data center at HBI, and therefore we don't have GPU resources available in computing the hypothesis scores. And so it runs on CPUs, which takes up some more time, especially with concurrent users. That's then an issue, but we are currently working on moving it somewhere else where we also have like then more resources available that it can be or should be more stable. Yeah.
I just see Hajai, if I'm not mistaken, raises their hand. Do you have any question, or was it just an accident? Okay, so we can move on.
Actually, sorry.
Yes, please.
Can you hear me? Yeah, well, actually, I had a question. That's why I raised my my hand. Thank you, first of all, for the presentation. I am a PhD student and I'm working on political risk analysis. And one of the methods I am doing is critical discourse analysis for political risk reports. And that's why I was interested to see your presentation and how this tool can be useful. And my question actually is related to that. Do you think it would be relevant or interesting to use the tool for a critical discourse analysis, at least for a first step for critical discourse analysis of political risk reports? to kind of see which assumptions, which clusters, and which categorizations emerge in those political risk. To put it simply, to see how the actors producing the political risk analysis, how they are producing it, and which political stance goes in the spirit of those reports. Do you think it would be relevant to use the tool for that specific case and topic? Thank you so much.
Well, why don't you have your hand?
Yeah, I wanted to say, I think this is the kind of situation which I think, as I was saying towards the end, I think you can view the tool as a means to kind of create the subset of data that you're trying to use within the critical discourse analysis. So if, for example, you're looking for that top 10% of illiberal language, for example, looking at political risk, top 10% of liberal language which might affect what clients are working with, then I think the APSI tool is something which can be really useful for really finding those outlier moments, and then you can use your critical discourse analysis to look at it that way. I think otherwise, with the kind of clustering analysis that you're talking about, I mean, one of the benefits of the model is that it gives you these discrete scores for each text that you're looking at. So I think you could also, I haven't tried it, so take this with a pinch of salt, but you could look into doing some kind of, I don't know, some kind of cosine similarity measurements between the scores that are produced for each text to try and cluster certain types of language, or some kind of k-means study to cluster the language that way. So I think that's a quite conceivable area which it could be used for sure.
Okay, thank you so much. I'll try it. Thank you so much. I'll let you know maybe through LinkedIn. Thank you.
Thank you.
So another question is, can we have a certainty score of the position, not just a thermometer bar?
Yeah, we want the APSI to be available for the general public, as we mentioned before. That's why we are presenting the bar, because we think it's less technical for for people that are not scholars. But yeah, if you use our version in the GitHub, you can obtain a confidence rate.
All right, thank you. Juan, and we have a question for Yuan. Would you have create a new core concept of technocratic speech for your example of quantitative research on slide 24, I think? Thank you.
Yeah, I'll be quick because we've got a lot of questions. Yes, you would. I mean, that's you saw the process that we showed within the pipeline, how we started with definitions from the existing expert surveys. You would have to go through that same approach to do that study. So you'd first take a definition or definitions of technocratic speech, define them, and then define hypotheses that you could then input within the classifier itself. So it's possible, but you'd have to change the hypotheses within the model to make it work that way.
We go to the next question. Can you explain the difference in the methodology with an existing AI like Claude, testing speech data according to specific criteria and classifying it in one category or another with your methodology? Why should we have more confidence in APSI?
Well, there are many differences. Both are AI-based systems. What it's different from using a large language model and using the APSI is basically the determinism. If you ask Claude to classify a text from 0 to 10 based on X definition of support for liberal democracy or populism, it will return a number. And if you ask again, it might or it might not return the same number. We have tested this, and we have seen that there are no deterministic, and we don't know why these models are providing different scores every time, because they are black boxes. Whereas for the APSI, if you provide a text and the text and the tool returns a score, and if you try again and test the same text, and then again and again, you will get the same score. And for each score that you input, you will receive the explanation of why the result is that number based on the hypothesis that we have. So we have the advantage of having deterministic scores. We have the advantage of having an explanation of our scores. And we have also the granularity, because it's pretty common to have models that classify in different categories. We provide the category, but we also provide the score from 0 to 10, which is something that you cannot find in other models. I don't know if you want to add something, Yorick, or you want? Okay.
I'd like to ask if you have looked at how your tool compares to a more LLM-based classification approach based on hand-coded training data. You mentioned using expert coding as a quality control, but does the tool perform more reliably than other possible approaches?
The model that we use, the political debate model, the paper reference shows how the performance is similar to larger models. This is mainly because while it's smaller, it is very specific. It's specific to political domain. So you don't have the noisy data that larger models have from data sets from Reddit or Wikipedia or other sources that contaminate most language models. So we haven't done the specific exercise of comparing it. The other thing that why we cannot compare it is because what I said before, they are not deterministic. So at some point, ChatGPT or Claude would return a 1.5. What, can you hear me?
Yeah, sure.
Okay. So at some point, ChatGPT or Claude or DeepSeek might return a 1.5, and then you ask again, and it will be a 2 or a 3. So it's hard to compare a model that provides a granular score versus one that it's always changing.
Okay, all right. And we have one more question for Yuan. How did you assess the quality of the output? Yuan mentioned expert coding obtained by APSI.
So when doing the application that I showed you guys, how do I assess the quality? I think so all of the top, so I basically looked through the top outliers first, right, to within the qualitative section, and I agreed with the way in which that they were analyzed by the model. I think one of the things that any AI model is going to struggle with is deeply sarcastic, deeply cynical political texts, and this is something that we see quite frequently within the Georgian context. So I think, as with any machine learning tool, you kind of have to take it with a pinch of salt and try it out for yourself to validate the results. That being said, obviously, we mentioned how it's been validated against the experts' results. And I think one of the important things to keep in mind as well is that there is, whilst we're approaching it this way, there is no single way that an expert is even, or 3 experts are going to disagree on the same point, on the same thing. So the kind of idea of a ground truth is very difficult in this kind of context. So within that regard, I think it performed well enough that I would be confident using it in academic work, for sure.
I'm afraid that's all the time we have for today. And thank you all for joining us.